Hello everyone and welcome. I gotta stop doing that. This is the wrong channel. Alright. Hello everyone. This is Dr. Staggs. I'll be your professor for this particular class this semester. SolidWorks is a really fun piece of software, and I think it's one that you guys are all really going to enjoy. It's something that is going to allow you to take an idea from the beginning to something that you might have sketched out on a napkin to a fully working functional 3D model in a digital space. And that's not something that is it's not a feeling that's very easy to describe, but what I will tell you is by the time you guys are done with this class, you are going to have an incredible sense of satisfaction about being able to completely construct something in 3 dimensions. And that's something that is something you will own in a way that nobody else can take away from you. So what kinds of things are you going to be learning? Who am I? Who are you? Who is anyone really? Let's answer some of the basic questions. But first, I always like to start out my classes with a foundation for the week, something that allows us to kind of set the tone in order to understand why it is that we do the things we do uniquely at GCU. This is something that a lot of students, I think, come in, especially students transferring in, that are not really sure exactly what all this stuff means. But a lot of times I will use scripture as a foundational point in order to set the tone for my class. So for this week, one of the important things that I wanted you guys to know about is this one from Romans. So Paul is telling us here that the invisible attributes, namely the eternal power and divine nature, have been clearly perceived ever since the creation of the world in the things that have been made. That sounds at first pass like just a bunch of gibberish, but in fact, this is something that is fundamental to all of engineering as a whole, and something that I really want you guys to think about and pick up on as we work our way through the semester. What we're actually going to be doing is learning how to take items and fundamentally deconstruct them into their component shapes and their axes of symmetry, and understand how to read drawings and technical drawings, how to develop those drawings, what to do with all of this information in order to construct and build and design functional 3-dimensional models of something, and test to see if we're using the right kinds of materials, if we need to use different materials, if it's too heavy, if it's too light. Is it going to be able to do the job that we intend it to do? It's all great and well to design a walker for the little lady next door, but if that little old lady next door goes to use it and you decided to make it out of balsa wood and she gets halfway down her driveway and then falls over, you really haven't done your job right? But instead, this idea that these invisible attributes fundamentally holding together the atoms of the world, what a bizarre concept for Paul to be writing about 2,000 years ago. I mean, what on earth? So this is something that I would claim is part of the divine inspiration of Scripture that shows us we can actually begin understanding some of those invisible attributes as they matter in the context of engineering. So, who on earth am I then? I am by background and training a research scientist. I spent some time at one of the nation's premier nuclear national laboratories. And there I got to play with a lot of really fun and interesting things. That was my first job coming right out of college. I went to University of New Mexico, where I got my bachelor's in chemical engineering, and so I was working with all sorts of things up there in terms of molecular monolayer coatings, lipid bilayer assemblies. I was also doing some laser machining, which you see here on the screen. Now, not this kind of laser. The ones that we were using were much more powerful than this. This laser is sort of adorable. That one's only an industrial grade laser. I was working with open class 4 laser systems. So That's the kind that can cut people in half, which really makes them cool, but also very dangerous. So there's a lot of things that I've got to do as part of those projects. One of those was making microfluidic devices. Quick show of hands, how many of you have ever heard of microfluidic devices? Doesn't look like very many of you, but that's okay. I don't expect you have. These are things that allow us to add lots of different materials into these different channels and bring them together in different ways in order to have them react and form shells and things like that, so we can use droplets to actually engineer devices in order to do something like drug delivery or something of that nature. A lot of cancer drugs, for instance, are things that are very hazardous to the person taking those medications, and when the drugs don't get delivered directly to the cancer cells, they are in fact very damaging to the person, and they don't really have a very high effectiveness. So one of the futures of medicine topics is always drug delivery vehicles, where we can take that same drug payload and almost like a Trojan horse sneak its way into the actual cancer cells or the tumor, and then use something like an ultrasound to rupture those drug delivery devices, or a pH release trigger responsiveness, or whatever the case may be, whatever we're trying to engineer into those droplets, and we can deliver the specific drug payload into those. So all kinds of wild and crazy things that you guys have never even thought of before. That's why I often get to say that I've basically seen a lot of what's coming in the future, and the future's pretty cool. So I'm excited to teach you guys some of what I've learned about how to use things like SolidWorks, for instance, to build some of those things. I've also worked in the area of biofuels and biofouling, and sort of what patterning and things like that do in order for changing the amount of energy required for cells to stick to surfaces. Part of that process was required for the biofuels work that I did. So I've worked with ethanol and butanol, and if you guys have questions about alternative fuels, why ethanol is really a complete mistake by our economy right now, and we need to be pushing for more advanced biofuels like butanol, I've learned all kinds of fun things about those, so come talk to me at some point about those if you have some questions. So I'm going to go through some of the basics of what to expect in the course, but one of the first things we've got to do early on is we need to get you guys downloading and installing this. So I think likely there's going to be on your tables some sheets with the serial number that you guys are going to need. So go to this web link to solidworks.com/sw/education/SDL form.html. So you can also get there by searching for SolidWorks and then SEK, as in Software Educational Kit, and that's what will get you there. I may have also posted a form in the week 1 announcement to LoudCloud, so go there and start downloading it. That is going to look something like this. So what you're going to see here is you're going to see an option for downloads. You're going to say English or your preferred language. You're going to say yes, I've already got a software number, because you're already going to have a serial number. The version you want to select, this is very important, you want to select the 1920. Then you want to put in your email address, your GCU email address, not your funnybunny21@hotmail.com address. Then you want to select, in your case, student, and then request download. So once you've put in your email, you're going to request the download. It's going to allow you to go through the process, and that's going to be one of the main things that we're troubleshooting today during class while we're working on some of the other things and the icebreaker activity, so that you guys can get to know a little bit more about each other as well. So as those are downloading and as you guys are walking through those processes, I'm sure you've downloaded 1 or 2 things, probably all legal, I'm sure, right? Let's talk a little bit more briefly about what it is that this class is trying to teach you as a whole, and then we'll get into some more fun applications as we go further into the week. Typically, the software install takes the entire day. So 3D drawing and design. This is a really, really large topic area. This is something that we use for every area in engineering at this point in time. Everything has to be prototyped, and we have to do design studies. We have to understand how parts are going to interface, how they're going to interact. We also want to understand how to draw them up and ultimately perform simulations to understand how things are going to flow. Is the shape going to be aerodynamic enough, right? One of the biggest things today in terms of engineering, maybe even more so than ever before in history, is efficiency. All of the manufacturers want 0 errors per 100 billion units of whatever they make. They want all of the cars to get 85 miles to the gallon. They want them to be completely aerodynamic, but also not look stupid. So how do you make a car look really interesting and then also not just make it look, not make it function very poorly in terms of efficiency? Because how many people want to be driving a car that gets about 12 miles per gallon but just looks really cool? Yeah, okay, there's a couple smart Alecs in the crowd. That's okay. So one of the things that we're paying attention to is things like, for a part like this, how many steps do you guys think is actually involved in designing a valve like this? How many think 10? Okay, how many think closer to 100 steps? No, a couple of you. How about 1,000 steps? How many think there's at least 1,000 different steps involved in this? A few of you, right? Now, how many of you have absolutely no idea and you're not even sure you're in the right class? That's also an acceptable answer. Okay, so what we're going to be doing primarily in this class is the SolidWorks software. We might sometimes use MATLAB for a couple things at a later point, but we'll have to determine that. This is something you're going to use for a lot of other classes anyway. But you want to make sure that your computer is compatible by going to the SolidWorks system requirements page. And the idea is, if you're running like a dual core laptop from 2002 and you have like 2 gigs of RAM, you're probably going to struggle in terms of hardware. Another thing that you guys are going to want to do, and this is something I want you guys to start trying to do early on, is get yourself a mouse to work with. See this? This looks really super fancy. Do you know how much this cost? $20 at Fry's Electronics, okay? There's all sorts of mouse options. I prefer a wired mouse myself because I have slightly large hands, and that means those little carpal tunnel mice drive me absolutely insane. I cannot work for long periods of time with those comfortably. The more comfortable you are with your tools, especially ones you're going to be using day in and day out in engineering, the more comfortable you're going to be and the less distracted you're going to be, the more efficient you're going to be with your workflow. All of those 5 minutes here and there adds up, because how many people have taught you so far that you need to be spending typically on the order of at least an hour to more like 2 hours outside of class time for every hour inside class time? See, that's what I thought. Not a lot of hands raised. So that's an expectation that engineering has on you as a student. The reason I know that is because I was an engineering student. In fact, because I went back for my PhD, I was an engineering student twice. Probably that means the pain receptors in my head weren't connected. But the bottom line is, you want to have good equipment that you're going to be able to use regularly, like a good mouse, that you're comfortable with, and that you're not trying to, you're not having to crane your hand and do all sorts of weird things with. So this is what we're going to focus on using. Grades for the class are broken up across a few different types of assignments, and this semester I think we've actually pulled the labs out of these, so we're going to ignore that for now. But participation, you guys that are not new to GCU will know that. For anyone who is new this semester to GCU, participation points means the points that you earn by being in class in order to be part of whatever the activities are that we're doing. So there's going to be a bunch of different things we're learning about as part of this. class, and we want you guys to be there in order to learn and really master some of these materials, because the overarching goal isn't just to get you guys to draw some 3D stuff and make it look cool. At the end of this class, we want you to actually be successful in building your resumes by having what's called an associate's level certification in SolidWorks. So this is an actual nationally recognized thing that you guys can add as a resume bullet at the end of this course if you're successful. And so that's our goal for you, is to learn a certification that can help get you guys jobs and internships. That's the motivation behind how we're structuring this class. So it's going to be challenging and we're going to push you, but I think we're going to have a lot of fun getting there along the way. Part of that is going to be having you guys do, instead of really quizzes as much, this semester we're going to be focusing on some skills and how you guys are mastering those skills as you're working along. So one of the activities I'm looking forward to, for instance, that's going to be very much quiz-like, although it's not going to be a separate quiz assignment, is it's going to be something that I'm going to have you guys make drawings of the parts that you create, and then you're going to have to swap them and see if someone else can create them. Now you're going to learn a lot about how that process actually works and what you need to include in a detailed drawing in order for someone else to be able to reproduce the part, right? So there's a lot of fun stuff like that that's coming up. There are some homeworks and assignments that you guys are going to have as part of this. That's just something we need to pay attention to as we go along. Everything should be in the LoudCloud calendar, and all of that should be updated now with more or less the correct due dates for everything. So keep an eye out for everything happening, especially along the dashboard for the class, because that'll give you a lot more information. So the participation is about 10 points per week. You have to be there in order to participate. Generally there's not makeup for the participation points, the only exceptions being the university excused absences. So GCU sporting events, not if you're going to visit them, but if you're actually on the team. And the other of that is if you're doing other university business. So like if you're on one of the sports teams, or you're at some GCU official event for the university, something like we will have something that we call HSET Day. So some of you that have been here already have probably been through one of those. For those, some of the morning classes that day won't meet, but for you guys the afternoon classes will still meet, so it won't really affect you. But that's another example of a university excused absence. So GCU clubs also tend to fall under that same event structure. So other than that, if it's, hey, I had to go to work, that's not going to count as an excused absence, and so you will be losing participation points. But again, that's only about 1.5% of your grade for all the participation points at the end of the semester. So the 10 points are primarily going to be distributed across what you're doing for the class activities. For the first week, make sure that you guys are posting to the class wall and answering the welcome discussion question both in LoudCloud. That's very important so that you guys don't get kicked out of your classes and you don't get your financial aid returned to the lender because you're kicked out of classes, and nobody wants that. So make sure you just answer both of those. You can put in an answer right now while you're in class that will count for both of those as your participation for this first week. But that doesn't mean you can skip the rest of the week and not learn all the stuff we've got to learn. So there are a couple big projects, and the quizzes, again, this is one of the slide sets I need to update. The quizzes are not going to be part of the structure now, which is actually much better for you guys. But there are still a couple big projects that you guys are going to be learning about. So there are going to be some things we're working on weekly. So the late assignments, so for this, the assignments, I will accept late assignment, but that's going to be subject to the standard 10% penalty per day. So one of the things that you guys are going to need to pay attention to is making sure that you are actually not just uploading files in a Word doc format or a PDF format, but you also have to submit them, because unless you submit them, neither one of us has an actual record of when you put that in. And that's going to be a problem. A lot of students have lost points over that, so make sure you're finishing the job by actually submitting things in LoudCloud. So my office is in 1342C, so third floor, just up the stairs, and kind of when you come up out of the stairs, it's to the left. So that's where one of our engineering office blocks is. Monday through Friday, generally speaking, 9:30 to 11. I'm going to be there. Tuesday, Thursday, 1 to 3. I'm going to be there. Otherwise, there's a high likelihood that I'm going to be in other meetings or in class. So, as you guys are continuing to get installs, I'm going to have whoever is instructing for me today, I'm going to have them walking around and helping with all of the software installs, because that's one of the hardest parts of the first day. Most of the rest of day one is going to be, I want you guys to check out this website and go ahead and take this quiz, and then I want you to collect your results and figure out which car you are supposed to be driving, and then I want you guys to get together in groups with other people that have either the same or similar cars, and I want your groups to justify, and so I want you guys to upload this to, let's see, probably upload this in the private forum in LoudCloud. Upload this in the private forum, what your justification is, as far as, is it the efficiency, is it the flashiness, is it something that's great as YouTube clickbait, is it something that's just maximum utility, or is it about all-out speed? So my examples, depending on how I answer a few questions, are either I should drive a Ford F-150, which I do have, or I should drive a Porsche Boxster, which I don't have, but I have something more fun for me than a Porsche Boxster. So the idea there is, this quiz I found to actually maybe have some sort of relevance. So I'm going to be really interested to see from where you guys are right now what kind of car the internet thinks you should drive. I'm a pretty big car guy, and that's part of the reason why the four-wheel drive car project at the end of this course is one of my favorites. So go ahead and get started on this activity, and I'm curious to see what your results are, and hopefully I'll be able to be back with you shortly. So this will be the end of day one, so you can go ahead and pause it, and then we'll come back for some of the day two skill sets and some other things. Did you pause it? What? Well, I told you to pause it. You should probably do that. Did we pause it? Okay, I'm just going to assume we paused it. So day two, welcome back everyone. I'm Dr. Staggs. I'm the instructor for this course for the semester. We covered some of the basics in day one, and there's a bunch of things that we're going to start working on, assuming all of the software installs went okay and most everybody's figure out where the classroom is and all of those things. We're also going to touch on, before we get into some of the content real quick, some of the key safety things for this particular lab. You're going to notice some signage up about making sure that you guys are careful around the printers. 3D printers are something we're going to use quite a bit this semester. We're going to teach you guys a lot about how to use them, but we also have to be really careful with those. There's a lot of things that can either pinch or burn you about 3D printers, and it's not a matter of it can happen, it's a matter of 100% it will happen at some point in time. So you want to be keeping your hands and feet and other appendages clear of the moving parts of the printer, because those have to get up over about 200°C. So that's not really something that you want to be touching accidentally with your hands. So you want to keep those clear. We also have a couple tools that we're going to be using later on in the semester, like Dremels, that we're going to be doing maybe a little bit of cutting and sanding for fit and finish of our four-wheel drive cars in order to make things work a little better. So we'll talk a lot more about the safety for those in general when we get there. But for now, today we're actually going to start looking a little bit more into the CAD environment and what that looks like. So in SolidWorks, go ahead and start by opening up SolidWorks, and we'll see if you guys can actually access the student guide. I think the most recent version of the student guide may not necessarily be accessible to you guys, so we're going to go ahead and start the program and see what it will look like. So assuming everyone has it installed, if not, take a look at what the instructions were from previously. There should also be an instruction sheet that's taped down to the table. So let's take a closer look here, and we're going to do a little work in SolidWorks. So we're going to open that up. It will start with some baseline menu. It's almost always going to tell you something in these alert windows about how it doesn't have enough memory. You could literally have all of the memory. No, I think you misheard me. You could literally have all of the memory that any of the vendors could sell you installed in your laptop with duct tape and however else you did it, and it would still say you only have 136 million gig. You need to close other programs to avoid a RAM limitation. So some of those warnings are a little bit silly and you should probably ignore them. So it'll open up and look something roughly like this. You may not have all the same exact menus, and I'm going to be throughout the semester kind of recustomizing mine. So I'll walk you through some of the common tools that I add to this quick reference toolbar and some of why that is. So one of the second day activities that I really like students to do is start by just opening a basic blank part file so you can see our screen changes. And so there's a few different things that we want to be focusing on today. Primarily it's the interface. Hopefully I will have gotten enough time to get together this scavenger hunt activity in the software itself so that you guys can start figuring out what these look like. So if we've got that, I want to go ahead and start with you guys doing that activity. So go ahead and pause the video here if that's been uploaded. If not, then I will go ahead and continue. So there's a few things that you're going to want to be able to use, especially off to the right side. So if you guys are able to access it, there will be under the library here, SolidWorks content. The design library is going to be very, very important. This is where your toolbox is and a bunch of other things. We'll learn a lot about what's in there and why we care about all that stuff. But the SolidWorks content, this is where we want to pay a lot of attention. So the curriculum, ideally you guys will have access to the curriculum for 2018 and 2019. This should be there should be a few different things in here. Fundamentals of SolidWorks 3D design and simulation. So this is one of them that you're going to want to download. So you'll notice when you click, it'll give you a few different options. So there's a few things here, some pre-made models and files, and what that looks like. I haven't downloaded the 2018-2019 ones, so I'm going to go ahead and download those. So you just double click, right? Well, no. You actually have to stop and pay attention to the little pop-up windows in SolidWorks. It says Control and then click to download the zip file. Okay, now it works. So instead, yeah, I guess I can include this in my SolidWorks scraps. Alright, so I'm going to go ahead and let that download. This is something that you guys don't necessarily need, but what you will probably want is this. So if you can access this, go ahead and download it. If not, then I will send it out to everyone. We already checked with SolidWorks and we have full permission to do that. So what that is a guide, basically. It's like a learning textbook in PDF form. That it will walk you through a lot of the fundamentals of SolidWorks. This is something you guys can start working on your own time and start learning just a lot about how SolidWorks works, what it is, and ultimately how to be able to design every single piece and part of stuff like this, for instance. So how many people are pretty intimidated by that right now? That's okay. That's actually okay. Especially if you guys have had some amount of experience in this before, or some amount of experience in 3D drawing in general. It's going to teach you a lot about how these things work. So it's going to walk you through some of the basics of sketching, give you some example exercises. So it's even going to show you what some of the buttons look like. Let's see, where's the starting point? Yeah, so it'll also point you to the tutorials. So there are some SolidWorks tutorials you guys are going to be actually working on as part of the homeworks for some of these. So you need to complete them and then submit them. There's also some rubrics that are going to go with those. And where all of that is located is actually going to be under help. So one of the things you're going to want to do at first is up around SolidWorks there will be kind of an arrow you can move your mouse over that'll expand this menu. I pin it because otherwise it's moving target and that can get pretty annoying. It's a lot more convenient if you just pin it and say, okay, now I want SolidWorks help. Well, how about the SolidWorks tutorials? Oh hey, that opens up a window with tutorials. So one of the quickest ways on your own, we're going to focus each day on some different kinds of specific skills, how and why to apply them. And one of the things that we're going to do is learn just some fundamentals about the interface. So there are a few that you guys are going to have to do. I think the parts might be one of them. So what it's going to do is you want to go to let's see, so creating and saving a document, for instance. So what these tutorials do and why we recommend you guys using these is there's these little orange boxes. So if you click it, it's going to show you in the interface what some of those specific buttons are, and it's going to help you start learning a little bit more about how to use the interface, how to save models, different options for saving, and then e-drawings and things we'll get to much later. Those are not really as useful as what we were hoping they would be, but each and every time they will show you what you're doing. So this is like an overview, and then they tell you how to get there. And so we're going to go over a few kind of basics today, but that's where the actual tutorials are located. So those are pretty helpful, but you don't necessarily need to use those immediately. So what's one of the first things we want to look at today? I want you guys to get familiar with the command window here. So one of the other things I want you to know is there's all sorts of things that can mess with the interface. Sometimes if you're working on one of the models inside, or one of the computers that are around the edges of the room, some of the time those will have lots and lots of reconfigured tabs and all sorts of just really strange behavior. So this one, the command manager can be gone, for instance. It can be missing, and then you can't find it. You're struggling to figure out where did all the things in the software go. I don't understand. You can always come back up here to Tools, and you can find under the Windows, under Tools here, there is the Command Manager. Where's this one? They've updated a couple of the menus, but this is part of what I want you guys to actually work through in order to get these to visualize. Let me see this one. So I guess they've moved it here to a right click for this version. That's a new feature that makes it a lot easier on you guys, especially if the command manager goes away, because that scares a lot of new users, and that's okay. So we're going to learn about the features things a little bit later, and so in some ways they should almost have the features tab elsewhere, but yeah, this is another example of, I want you guys just to play around with the interface and see how many different ways you can break it. So this I actually don't want in the side or anywhere else. I always want it up there. So what you guys saw there was a case of dragging the command manager. There's different options. Sometimes you may see some jerkwad put it over here or whatever. You can customize the menus by picking which side you want them to be on. I find it's easiest to just leave it at the top. This is some of the little stuff that I want you guys to start paying attention to about the interface before we get too far into the drawing itself. So as far as the drawing itself, most of the time right now we're going to be focused on things inside the sketch part of the ribbon. We're going to learn much later about the evaluate and about some of the other dimensioning, some of the add-ins and things. Just to eliminate confusion for the moment, I'm going to pull out the simulation and the toolbox components so that I have fewer tabs up here, and that way my software looks closer to what yours does. We really won't get any into CAM for this particular semester, but there's a few different things that we want you guys to learn about, and in order to start doing anything in any of the sketches, this is where we have to start. So this is the fundamental interface. We don't have any part or sketch started yet. This is some unnamed part, so what you want to always do is save this as, and so mine, I'm going to go to SolidWorks scraps, and I'm going to say this is 19 example 1. So what we're going to do is play around with this and start learning what some of these key tools are. So we want to start by focusing on where some of the basics are. So to start or begin a sketch, typically we're just going to click sketch, and then there's all these different planes. So we're going to talk a lot later in the semester about how we want to think about if we pick up an object of some sort, like say your evil professor makes you recreate, after measuring very carefully, a 3D travel mug. How many of you would be absolutely terrified if I set this down in front of you and said, draw it right now? Probably a few of you would be sitting there going, what on earth do you mean? Well, I'm going to show you. One of the first things we want to think about is we want to think about what is the common geometry of something like that. So if we were to try and draw a shape, it's something that sits vertically. So if you click the mouse wheel, if you have a mouse today, it's a lot easier to see what this looks like. You can rotate the view around in 3D from all these different planes and get a sense of where you are. You have the origin visible here in terms of which directions each of the vectors are pointing. So for something like that that's standing up, we think of the top plane as being the top of something, the right plane being the side view of something, and then the front plane being the front view of something. So for this, we'll go simple. We're just going to select the front plane. So now we are what's called in a sketch. If we are working on something and we have to work on two different parts, and as we get into 3D, we're going to want to be able to step in and out of different sketches that we make
to create different features of different parts. That can be a little bit confusing because now I just stepped back out of the sketch, and if I go to make a sketch again, it says, well, you were on the front plane, but is that still where you want to go? I can either go to the top or the right, but I want to stay on the front plane. I just want you guys to know early on that we're starting at a front plane sketch for this. We're stepping into a sketch to make it. Then we will step. Almost always we will be stepping out of the sketch in order to make it from a 2D feature into a 3D feature. So we're going to focus the first part of the course on 2D, but this is why some of this stuff might seem easy for some of you and really confusing for others. We have to lay this foundation in order to be really good at making parts later. Another really important part of the interface is down here. This is what gives you the dimensions that you're using. I almost always work in millimeter gram second. Sometimes the default will be set up to inch pound second. Depending on what you're drawing and in what context, it'll have to change, but it doesn't really matter which set you're using so long as you're consistently entering dimensions. And that's what we're going to learn about for the Smart Dimension feature later. I think we're going to focus more on that on Friday. So for now, let's start with a simple line. Simple, easy, basic line. Started at the origin, and we'll learn what these different kinds of white and yellow boxes that are appearing. We'll learn a lot more about those specifically on Friday. Right now what this one's telling me is that this is parallel. Now I'm at some kind of an angle. Now I'm parallel again to another axis. Now I'm at some kind of an angle. Now I'm parallel again, some kind of an angle, parallel again. So I'm still in 2 dimensions, but I'm sweeping all the way around a clock. So I'm just going to draw it this direction. Okay, so there's a line. Now I can either continue to draw lines that are connected, and I can make them parallel. I can make them at an angle, parallel. I can make it perpendicular. There's a center point there. So here it tells me something about an angle. So I can make a pretty good guess at what might be almost a triangle or something like that. And there's all these different kinds of reference points that we're going to learn lots more about as we go farther into the semester. But this is the basics of how to use lines to start connecting a geometry. So try and see if you can use a line to make a square and a rectangle and a triangle. Give that a try real quick with the line tool. And the instructor, whoever's subbing for me, can kind of walk around and answer any questions, especially if you're struggling to find where those tools are, or you're lost as far as the ribbons or things like that. So go ahead and pause here and do a little troubleshooting real quick. Did we pause? Oh, I see. Everyone's an expert now. Okay. It's just like the YouTube comments section. Everybody's a doctor, a lawyer, and a physician, and a theologian, and all kinds of other things. A scientist. All right. So another one that I want you guys to learn a little bit about under the lines. Each of these different shapes has drop-down menus. So there's a couple key things, one of which is a center line. So it'll still look like a line, but I have center line selected right now. So what it's going to do is, in that case, I had clicked a little too early. Anytime you click, another good habit is anytime you click mistakenly, hit the escape key. That's going to be one of your best friends in SolidWorks. So there's a couple different options for what I can do for a center line. But a center line is used just like what it sounds as a reference point. So I can set this at an angle, I can set this at another angle, I could run this through a center line of something else, I could associate it with a center line of something else, I can make all kinds of relations. This is why we're going to learn more about this on Friday, because that turns out to start being very, very important on what we're doing. For now, what I'm going to do is just set a center line along the axis. So this is a line that doesn't actually become part of your geometry But a center line becomes really, really, really important. And the reason why is we want to be able to often reference some distance away from the axis so that we can only have to draw half of a shape and then perform some operation on it in order to leverage the symmetry of something. So a great example would be this travel mug. If you take off the lid, and you imagine taking this lid off, I'll hold it up to the camera a little bit better so that you guys can maybe see it. Let me check the outgoing message here and send you guys down the infinity hole. There we go. Yep, scale's about right. So as you rotate this, it's the same all the way around, except for the lid, right? So there's some things that we can take advantage of when we're trying to build different sorts of shapes. Those are some of the things that we want to be doing. So the center line is very, very, very useful, and something that you guys will be using as reference points for dimensions and all sorts of things. You can add them really anywhere in your drawing in order to establish a distance between something and something else. So there's a lot of capabilities that we have for center lines. So see if you can draw a couple center lines using a couple of these different techniques, and see if you can connect some of these key features something like that, so that you can actually connect a couple different points from a center line to a geometry and so on. So let's pause here again and do some quick troubleshooting and practice. Alright, and we're back. So now what we want to focus on is how to actually use those center lines in order to do neat and exciting things. One of the things that we're going to focus on is some more basic shapes. Splines are something that can be useful for some specific applications, but we're not going to focus on them very heavily right now. What we are going to do is a lot of different rectangles and different circles, things like that. So rectangles, corner rectangles. What that does is you grab a corner and you set the other corner. Pretty basic, pretty simple. But sometimes that's not really going to be the best option for how to draw something in your shape. So what about a center point rectangle? Well, in this case, a center point rectangle is something that we start at the center point, and then you have what look an awful lot like center lines, especially if we zoom in. That's another pro tip, is if you scroll the mouse wheel back and forth. Again, it's day 2. If you guys haven't already gotten yourselves a mouse, that really needs to happen soon. The software doesn't cost you guys anything, so you really may want to make sure you're using a mouse. You also want to make sure in settings, or under options, under, let's see, where is it at? Is it under view? Yeah, reverse the zoom direction. Only noobs zoom backwards to zoom in. So don't be a noob, be a pro. Zoom in when you zoom in, zoom out when you zoom out. It makes a world of difference, I promise. Many of my students have said that one thing has saved them hours of their lives. So here's some of the other quick things that we're going to do for this. Center point rectangles are useful. You can also establish 3-point rectangles. So maybe you say, yeah, I need something here, here, and here in order to be a reference point. So what I did there is I had to establish, oddly enough, 3 different points of the rectangle. But that can be very, very helpful if you've got part of a geometry that you need to connect things to. And as we start to learn some more basics in the infrastructure of SolidWorks, we're going to learn a lot about how to make that happen. So another useful one is the center point rectangle. So I think this one sets at, for instance, an angle. So here I can set it at a slight odd angle. So if we need to set something off at a bizarre angle, this is a much quicker way to get a basic rectangle, but not in a 90-degree sense. So it allows us to do some pretty interesting things. And then we can even do parallelograms. Neat, right? So go ahead and see if you guys can make some basic fundamental shapes using just these different types of rectangles, and make sure you use at least 3 of the different types of rectangles to make a shape. So go ahead and pause this and do some troubleshooting with the kids. Alright, and we're back. So now we've done some basics of rectangles. We also want to take a look at circles. So those tend to be pretty important. There's 2 main types. One is the center point circle. The other is the perimeter circle. So I need a circle here, here, and here. So depending on what we're trying to do with our shape, at the moment we're sort of going a little bit modern art right now with all of our fun features. But this is an easy kind of way to say, all right, I need to, maybe I'm trying to design a wheel and I really need to make sure that we can pass the MCM shoe test. If you don't know what the MCM shoe test is, then you probably haven't used the internet enough, and you're kind of missing out. It's the idea that if you have a really tall vehicle and you have really tiny wheels and you can shove lots of tennis shoes between the wheel and the fender, then it fails the shoe test and your car needs to be lowered. That's what that means. So if you were trying to do that and you wanted to trace the fender at 3 different points, you could say maybe it was an arc, and I'll just do a quick example. So maybe this was the arch of the fender, right? So if that was the case, we could come back in here and we could do a 3-point circle and say that one, and that one. And that would pass the MCM shoe test because you're not getting a shoe in between that gap. So that's a quick way to use something like a 3-point circle if you need to match a partial radius of something. So there's all kinds of great tools that you guys can do, and I'm really excited for you guys to see what you can do when you take that and extrapolate it into 3-dimensional shapes, start learning about clearances and tolerances, and really how to make use of all of the powerful capabilities. So see what kind of modern art you guys can come up with and what kinds of shapes. Maybe you can make Mickey Mouse wearing a Vader mask or something in 2D. So play around a couple bit with these different shapes and see if you guys can come up with some interesting designs. And go ahead and walk around and make sure the students are able to find all of these and follow along. So go ahead and pause this. Oh, you didn't pause this because they were experts? Alright, well, we'll keep going on some of these. So probably for day 2 we're just about out of time. If not, another fun one is the polygons. So we can say we want it to be a 32-sided polygon, and we want our center point to be here, and we want it to have an effective radius of whatever this is. But actually we say, that's too many. Let's do 18 sides. No, that's not pointy enough. Let's do 9, because 9 is an uneven number. There we go. So let's do 9. Another quick interface tip that's probably about the last one for today is holding down the control and clicking, holding down control and clicking the mouse scroll wheel at the same time allows you to move the sketch around. And those 2 things, being able to move the sketch and zoom in and out, will allow you to do lots of great, incredible detail work on stuff in no time. So go ahead and play around with the polygon and see what kinds of interesting or unusual angles you guys can actually come up with. And then when you're done with the polygons to insert them, click OK, and then hit escape to deselect those. So go ahead and get a little bit of practice with those as well. All right, so today I'm assuming is about day 3 in this part. So hello everyone, I hope that most of you have been able to be in a couple different classes now. So this is Friday, so you've made it to the end of the first week. Congratulations, that's good. If you are new, welcome. I am Dr. Staggs. I'm the instructor for this course this semester. Sorry I couldn't be with you. There's a couple things keeping me very, very busy, namely one mostly new kid and one very new kid. So, we're going to learn a little bit about skill focus today, and what we're going to be focusing on a lot more is relations, some of the basics for smart dimensions, and a quick way to use some of these basic shapes to do an extrude and a revolve. So I'm going to assume that you guys have all gotten the software more or less installed and figure out now. Hopefully you've attended some office hours for some of the instructors or gotten some help if you had struggles with that. If not, you guys really need to make sure you have that, and make sure you get yourself a mouse. If you don't have a mouse, you are setting yourself up for very great heartache and hardship in this semester. Make sure you get a mouse. You can get a really great mouse these days for not a lot of money. So I think there's a whole Linus Tech Tips episode about just mice, specifically gaming mice, and a lot of them are really cheap and work really great. So pick yourself one up. All right, so what are we going to be working on today? Well, here we go. So we're going to open up SolidWorks, and we're going to start with a new part. So I'm just going to make a new part so we can start with some of the things we did yesterday, but we're going to continue to build on the capabilities that we've already got. So what are we doing first? So one of the things I wanted to touch on was relations and what that actually means. So for that, I'm actually going to be doing a center line. So I'm going to start a sketch. I'm going to pick the front plane again, and I'm going to start a center line. Now, what I'm going to do is I'm going to start by saying this one is what's called a concentric point. So a point starting that is connected to a line somewhere. So concentric means it's actually going to touch the line. If I move it just a little bit, it's no longer going to touch. So you have to use the information that these little boxes are telling you. So to the left of the pencil, we know we're drawing. We're not selecting, we're drawing. That's what the pencil means, and it's not the arrow. If we deselect that by hitting escape, we go back to the cursor, right? So if we're drawing a line, especially a center line specifically, we get a pencil with a center line. If we change it to a regular line, it'll be a pencil with a regular line. Gee, that's funny. It's almost like they paid attention to what they were doing. There's also a midpoint line. A midpoint line is also helpful, and so you'll see the same two basic relations here at first. There's this one, which is basically meaning it's tangent to or adjacent to. So this is a coincident point. Coincident is actually what they call it in the drafting competencies. So this is coincident, meaning on the line. So we're going to start, because this is a center line, we're going to start and look. This is a line where that was the center point. So then it goes to regular lines, and we can continue making a shape. But we also want a center line. So the center line is going to give us a reference point here. So there, it's not only concentric, but it is also parallel to this axis. So that's what those two things are. So now, if we look, there's also center lines you can do with arcs, depending on what you're doing and how you sweep this past. So you can have it be a center line, or you can have it be an arc reference line. So if you need some sort of a reference curve, there's lots of different things you can do with those. What that tells you is that this is at an angle, specifically 270 degrees. This tells us a reference angle of 180, or a reference angle of 90. So each of those are a possibility. In this case, I'm going to just do a quick reference. So by sweeping back and forth, I'm able to select which type of axis. So you notice, depending on which direction I'm sweeping the pencil away, I'm sweeping the center line down, or I'm sweeping the center line to the side, or I'm sweeping the center line up, or I'm sweeping the center line down. In this case, I'm sweeping the center line around along this axis, and now I have two different axes. Because these aren't of equal length right now, I'm not going to be able to get an even curvature, but one of the things that we're using today is going to be really helpful with this. So it's called Smart Dimension. So I'm going to say I want this dimension to be, let's say I want this dimension to be 50, and the default is millimeters, but if I put in 50 inches, then it'll set the default to 50 inches. If I set it to be 50 millimeters, it'll set the default to be 50 millimeters. So anytime we're entering dimensions, whatever system we're in, we can always go back and change that. But once it's changed to a black dimension from a blue dimension, it's what's called fully defined. So the computer knows everything it needs to know about that. So now I'm saying this one I want to be 60 inches. So now you notice this dimension changed as well, because this point is coincident with the arcs. So what that means is, by establishing these relationships, as we start changing some of the dimensions using the smart dimensions, different parts of our model, different lines are going to stretch and change or shrink and move depending on what relations we're trying to define. If we try and define too many, it's going to tell you an error and it's going to be overdefined. If you haven't given it enough, it's going to leave some things blue, and so those are going to be underdefined. And so what I need now is I want this to be, actually, I want to use the smart dimension between, so that one is still going to be a 90-degree arc. But I can define the radius if I want to. So 1560 is our radius. So this one I can actually also do some clever trickery. See that when I said that overdefined message, there's a few things that'll happen. So what it's trying to tell you is, wait a minute, if we move this dimension that right now is this center line, or this center point rather, this origin for the arc, is coincident with this line, but it can't also be coincident with this center point and all of these other relations at the same time, because the arc physically won't work. And so what that'll do, if you just say, okay, I don't care, and you try and move it, especially if you try and say this dimension is 0, you can't change it because you have too many things already established. So what do I need in order to change that? I need to recognize that this dimension is monkeying with what my other dimension is. Now, if I set this to be, if I set this dimension, I need to move this here. See, this is what it was trying to tell me is, well, now I can't keep that same length and reach the arc that you want me to. So at the end of the day, what do I have to do? Well, now there's a couple other things that I can do. So I can add another relation, and I can actually make these two things equal. So I can step out of the smart dimension, and I can say this. I can have that highlighted. I can right click this. If I right click both, I can zoom in to look at both of those, but what I want to do ideally is set this one equal to this one. So this is our smart dimension, feature that allows us to scale things down to equal. So if I set this to 1270, now what I've done is made these two equal, and I have a defined arc. So now I could come in and trace that arc or a bunch of other things, and I could be I could get some pretty good progress going. So now that I have the center lines as a reference, I follow along with the arc, and I have two sides of something, and now that this is especially even, there's a couple of ways that I can do this, but what I want to do is I want to take this shape and I want to revolve it. So I can connect this with a line. So now this whole sketch turns black. I didn't change any of the dimensions, but what I did is by having those defined relations and by having the midline, the center lines, but setting those as reference points, using the coincident references, I was able to get this sketch to be fully defined, which is always the goal. Once a sketch is fully defined, now we can start doing some really interesting things with it. So one of those is an extrude, and so we're going to take a look at that, and then we're going to take a look at a basic sweep as well, and then we're going to have you guys do a little bit of practice. So first I want you guys to practice some of this on your own, come up with a shape using some of these tools, using some of these basic shapes, come up with a shape, help yourself by using some center lines as some reference points, and using the smart dimension to rescale some of the different angles, some of the different dimensions, so that you can get the shape that you want in the size that you want. And then we're going to show you some of the things you can do with those, but you want to try and get to the point where you have, instead of all the blue lines, all the black lines, so it's a fully defined sketch. So this is a lot of things to start trying to do already, and it's a Friday, but that's okay. So go ahead and pause this and get some practice in. It's okay, I'll wait. Okay, so this is what we're going to start doing now. Is we're going to do a couple basics. Now that we have a fully defined sketch, what we're going to do is we're going to hit escape. Okay, so we're out of the sketch now, so you can see the whole thing is blue. We're stepped out of the sketch. Now we're going to perform some operations. We'll learn all about some of these basics throughout the semester. The easiest one is an extrude, and what you want to do often is you want to grab maybe one region instead of another. For this, I don't necessarily want this. I just want this region inside our half circle. So one of the things that we want to start thinking about as we're getting from a 2D perspective to a 3D perspective a little bit, we're going to focus mostly on mastering the things in 2 dimensions before we start really bringing it up into 3 dimensions. But this is some of the quick tools that we can use pretty effectively. Most of the time for the default settings, you're going to always deselect this thinning feature. It is exceptionally annoying. It is mostly, for most of the things we're doing, completely useless. So you deselect that, you come up here and you check the OK box. You can also look at a detailed preview and some other things, but you want to, from the sketch plane, extrude it 10 millimeters. So you can see this actually has thickness now. So this actually has thickness, and we are able to make it work for a few different things. I can go back and edit that now. If I don't know that that was the right thickness, maybe it actually needed to be 100 millimeters because I didn't pay attention in UNV 112 when someone taught me how to do unit conversions again, right? That happens sometimes. So now we can see it has a little more thickness. So there's also things that we can do that are really fun if we edit that, and we can say, actually, I only want this region, and I want to delete region 2. So now I can just do half of my region because of how I did this. Now I can go back and I can do something that I didn't know about until a little bit later, but I'm going to show you guys early so that you're way ahead of the game. You can come back and you can do another sketch, and so you can edit the sketch, but now you can say, actually, I want to do, so no, I have to be outside of the sketch. I can do another extrude, but now it's going to tell me, wait a minute, I have to have something selected in order to extrude it. So up here, this is what's called my part tree. I want to select the part tree. I want to drop it down and say, under this boss extrude, there is a sketch, because I can only make an extrude based on a sketch. Well, now I have options. Well, okay. So what I want to do is I want to select this region, which I didn't do an extrude on yet, and I want to get rid of the thin feature because that does nothing for anyone. But up here under direction, I want to reverse this, and I want this to be 1,000 millimeters. So you can also pick the units manually, but millimeters are fine for this. And this is still going to be a blind extrusion. It's still going to be from the sketch plane. So we're not doing anything fancy yet. But now I've made some sort of really unfortunate modern art chair, right? How you sit in it, I don't know. That's why it's an art chair. I don't think they actually sit down for very long anyway. So now we've made our little modern art chair all from one single sketch because I left in one of those center lines. Otherwise, I could delete it and make an easy single shape, or I could say, well, actually, maybe I wanted to do both sides for that one. So now I come back here and say, as far as the sketch regions, I also really wanted that region too. So now I have a different sort of shape, but you can always go back and edit or modify these at any point, and then you can also use the same sketch for multiple different extrusions and revolves for lots and lots of different things. So for now, what I'm going to do is I'm going to step back. Another really important thing to notice is there is a Control Z, so you can undo all the stuff you did, but you can't go back and redo it. You can only undo more things. So careful when you undo things. You're only going to be able to go one way. So first, before I show you the second technique, I want you guys to practice extruding all the different fun and interesting shapes you guys have come up with, so that you guys can get some hands-on practice with this. So go ahead and pause and we'll come back in a minute. Alright, and we're back. So what we're going to do this time is going to be a little bit different. I'm going to show you a basic revolve of the base. So this is a very different sort of technique. This is one that allows us to use an axis of symmetry to rotate something around. So this is how we make sometimes spheres and cylinders and things that have that sort of sweeping geometry, not to be confused with the sweep feature, which we'll learn about later. So there's some very interesting ideas on the sweep and how to make those work. So for a revolve, what we're going to do is, again, we're going to pick our sketch 1 because that's the thing that we're interested in, right? The axis of revolution, this is always really important. So this, it already picked the center line, which was line 2 in that sketch, the second line that I drew, because I drew the first line, then the second line. The reason I'm encouraging you guys to start already with center lines is because you can use those as axes of symmetry, and the software will recognize that, so it'll save you a lot of headache and heartache down the road, even though right now it seems like, why don't you just do a line like regular people? Well, because I know stuff that you don't, it's kind of like I'm from the future, so just trust me on this. This center line is what's going to be our axis of revolution. Now we're going to be able to revolve it. In this case, a blind revolve is fine, 360 degrees. I'm always turning off the thin feature. If I could go in and delete it from the software, I probably would, or if I could disable it from my interface. So now I'm going to select the contours. So I want to sweep these. Now, you noticed, interesting. So what is this shape? That's a half sphere or a hemisphere shape. This is a whole sphere shape. So now, no matter which way you rotate it, this is a spherical object, right? So what we're doing, especially if we have a fully defined sketch, now what it's doing is leaving me the other reference lines in the sketch, but it's used all of the solid lines, so all of my other reference lines that weren't used in the sketch are still present so that I can see what they look like. This is another effect that I wanted you guys to be able to see. If you start getting in the habit early of using lots of symmetry with center lines and reference points, and that's what you're using as your basis for dimensioning your projects, it is going to save you so much heartache and headache, especially when it comes time to go to do the actual exams. You will thank me for that later. Just because of the amount of utility you will get out of this. So you can have a finished sketch with all sorts of interesting things. And actually, this is a very timely reminder. You guys probably can't see it because my face is covering most of it, but the unsaved document notification, you haven't saved for at least 20 minutes. So that's because I've been recording and trying to make sure people have things that they can work on while I'm gone. So you want to often save and update all the time. In this case, this is, this can be in whatever number of parts. So this one I don't need to save at the moment, but that's because I know how to get back here very quickly. So there's a couple things that we can do with a revolve. One of the other key features is we could say, oh, actually, I want to undo that revolve, but what I want to do is I want to make one more reference line. So I want to edit this sketch. So if you hit sketch again, it's going to make a new sketch, typically. Now I had already selected that sketch, so if you select it, okay, that's a helpful feature. If you select it in this version, if you select the sketch and then hit sketch, it'll automatically start editing. Otherwise, it's going to start a new sketch and you have to figure out a new plane to work on. So we'll do that later. That's a thing that we'll work on later. Edit the sketch is always the way to make sure that you are working on that specific sketch. So if I'm editing this sketch and I say I want to add one more center line. So right now this center line is parallel, using that relations information. Parallel. This, the circle, means concentric, the two circles, meaning that that center line and the other line, those 2 points are going to be exactly the same, and then that one's going to be tangent. So now I have two relations that are happening. One is I am coincident, so I'm touching on that center line. The coincident is right here. and the other is that I am parallel to the other line in my sketch. So by setting up that center line, it doesn't have to be very, very long, but I can click and drag either way, and I've still got the same relation on that line. And you can see both of those in green, so parallel and coincident. So we can see both of those. The last thing that I want you guys to be focusing on practicing for today is this revolve. So I want to revolve both of these, and again, it knows that I put up a center line, and so it's automatically detecting what side, or it's automatically expecting that I'm going to be using that center line as a reference point. So if you get in the habit again early on of making center lines for reference points instead of regular lines, you will make life so much easier on yourself down the road. And future you will thank you when you pass the CSWA exam the first time around, instead of having to wait till a redo or something like that. So this is a shape that should look roughly like a washer or something that gets used as part of a cap screw, right? So what if we changed that and we used both sides? What does that start to resemble? Well, that starts to resemble almost like a donut, also known as a toroid. So my kids are probably the only kids on the block that are going to start learning how to say those stacking rings are toroids instead of stacking rings, and other people are going to look at them strangely, and then they're just going to say, my dad's an engineer, don't ask questions. So toroidal shapes are a very, very powerful technique of the revolve, and it allows us to do lots and lots of interesting things with an axis of symmetry of revolution. If you can rotate the same line around an axis, you can begin to replicate a lot of interesting kinds of shapes in 3D from very simple two-dimensional sketches, and save yourself a lot of work by leveraging the power of this technique in order to do some interesting things. So this is another great opportunity to pause and get lots and lots of practice with several different shapes. I want you guys to revolve at least 3 or 4 different kinds of shapes, different geometries, around several different types of axes, and see if you can make all sorts of interesting toroidal shapes. And then eventually we'll teach you how to do that with a rotational twist element. There's all sorts of crazy and interesting things that can be done in order to make those work. So for now, that's what I want you guys to practice on. So go ahead and pause here and get lots and lots of practice on this. Alright, did you pause? Okay, so this is basically what I wanted you guys to focus on today. There is an assignment coming up where you're going to use a lot of these specific skills. I'm going to assume that probably with all this extra practice, you guys have taken up basically the whole class, so we're probably in the last few minutes. Make sure, especially, that you guys are making use of your instructors, asking questions in the private forum, making sure to ask public questions in the QI forum. So maybe you guys should be posting lots of regular questions in the questions to instructor forum about, hey, I'm having trouble finding this, or hey, why are we doing this instead of that? Make sure that you guys are following up with office hours. I don't know all of the other instructors' office hours. There's been a lot of flux around that. So Dr. Quarterwitz, Dr. Williams, Dr. D, as well as Dr. Kong and myself should be able to answer lots and lots of questions should you have them, and make sure that you're making use of as many of your resources as possible so that you guys can be successful. And this weekend, if you haven't already gotten one, do yourself a favor and get a mouse. It's not that hard. You will thank yourself for doing it. So with that, I want you all to have a good weekend, and hopefully I will be able to see you next week and things will return to normal. Otherwise, I'll have to keep joining you from the future or the past. Time travel is so tiring. So that's all I have for you guys. Thank you guys. Have a good weekend. Down the rabbit hole we go.